Hello student, in this video we are going to discuss about the activity based on the normal distribution. So for that particular part we are going to consider data of the CGPA of the students, and this data containing about if we just look at the number of entries, so it will contain around 1739 entries where the data is given in the form of CGPA of the student. So in this particular activity we are going to discuss that firstly that how do we check that either this data follow a normal distribution. Okay, so we are going to calculate the probability of this particular data in the form of a, firstly we convert this data in the form of a frequency distribution, and then we can calculate its probability, and further we'll calculate the probability of this particular data with the help of normal distribution also, and we'll try to relate this data and we'll try to check that either it will follow a normal distribution or not. Okay, so before we'll start with the activity, firstly we need to understand some of the concept of the normal distribution also. Like the first main important point is a random variable x is said to follow a normal distribution with the parameter mean mu and the variance sigma square. Okay, so here this parameter mu represent the mean of the distribution, and this parameter sigma square represent the variance of the distribution. Okay, so in that case its probability density function f of x is given by 1 upon root 2 pi sigma e raised to the power minus 1 upon 2 sigma square into x minus mu whole square, right, where the value of x varies from minus infinity to infinity, right? And the nature of the normal distribution means that it has a bell-shaped curve which is symmetric about the mean. This is a bell-shaped curve which is symmetric about the mean mu. Okay, and basically this curve is asymptote to the x-axis. This is minus infinity to plus infinity, right? And if we want to calculate the probability of the random variable, say in the interval a to b, so the first step is we need to transform our random variable x into a standard normal variate. So what is a standard normal variate? Standard normal variate is z. It is denoted by z. Standard normal variate is z, which is equal to x minus mu upon sigma, and it will follow normal distribution with mean 0 and variance 1. So that means when we transform it into standard normal variate, then if this is the curve of the normal distribution with mean mu and variance sigma square, that means this particular part is say sigma. In that case, when we transform it into standard normal variate, then the standard normal variate also follow normal distribution. Standard normal variate also follow normal distribution which is symmetric about origin. Okay, and in this case also its value varies from minus infinity to infinity, but you can say that about approximately 99 point, if we say that from 99.73% of the area is lies between minus 3 to 3 only, right? Okay, this is the basic information which we need to know. The important point is if we want to calculate the probability of the random variable x in the interval a to b, the first step is we need to transform our random variable x to a standard normal variate z, because we can calculate this probability with the help of the standard normal table. Okay, so for that particular purpose we need to transform x into z. So how can we transform it? We need to convert x into z, so it means that we need to subtract the mean of the distribution throughout and then divide by standard deviation, because standard deviation is positive, so there will be no change in the sign of inequality. So a minus mu upon sigma is less than equal to x minus mu upon sigma is less than equal to b minus mu upon sigma. So if I say name it as a capital A, this particular part, if we name it as a capital A and we name it as a capital B, then we can say that this is equal to probability capital A is less than equal to Z is less than equal to B. Okay, so it means that basically if I want to calculate the probability from the point A to the point B, then how can we calculate this? So it can be calculated like, so we calculate its probability up to B and then we subtract the probability up to A. This is the area property, right? So this is equal to probability Z is less than equal to B minus probability Z is less than or equal to A. And this is nothing but, we can say that this is the cumulative distribution function of Z up to the point P, because the cumulative distribution function f of x is defined as probability x is less than or equal to x, right? So in this case, if z is less than equal to b, so it is denoted by f of b minus f of a. Okay, so this is how we can calculate the probability in case of the normal distribution. Okay, so this is the initial thing which we need to know. Let us come back to the activity part. So in this activity we are given a data of the CGPA of the student, where the smallest value, if we want to see the smallest value, and because the data is already sorted in a decreasing order, so in that case we can sort the data in an increasing order by using the option of data, and then we choose the option from A to Z. So it will sort the data from smallest to largest. So we find that the smallest CGPA value is 0.86, and if we want to see the largest value, then we can sort the data from decreasing to increasing. Then we find that its largest value is 10. So what is the maximum value? And the maximum value is 10. And what about the minimum value? So the minimum value is 0.86. okay, 0.86. okay, so this is the initial information we have. Now this next step is, because I want to calculate the probability and I want to compare it with the normal distribution. The first thing we need to know that the normal distribution is the continuous probability distribution. Okay, and the given data is in a discrete form. You can see here the values are given 10, 9.72, 9.67, 9.53. Although the value is calculated up to 2 decimal places, but there is no much values are there between any two consecutive numbers. So this is a discrete data. So the first step is we need to convert this data into continuous form. So for that particular sake, we need to convert this data in the interval form. So if I want to convert this data into the interval form, we need to firstly decide that what is the width, okay, between the two consecutive points, right? So for that particular purpose, like what can we do? Like if I arrange this value in a increasing order, so 0.86 to 0.48, so basically the data is from 0 to 10. okay, and if we want to draw the distribution and I want to compare it to a normal distribution, so I'm expecting minimum 15 to 20s or 10 to 15 entries must be there. Okay, so for that particular sake, suppose that I'm going to consider the width of the, that is the length of the interval is say 0.5. okay, so I'm going to decide the bin value. What is the bin value? Bin value is basically the length of the interval. Like what does it mean? Suppose that we are given a data in a discrete form, so 1, 1.12, 1.23 and 1.345, and we have a 1.47, and then we have a 1.6. so what can we do? We can convert this particular data in the interval form. Say I'm taking the width size as 0.5, so I want to see that how many numbers are between 1 to 1.5, then 1.5 to 2, and then 2 to 2.5. Okay, so this difference between these two value is called the width of the interval, right? And we can express it in the form of bin as, so in the bin we are going to consider the upper limit only, right? So I can write it as 1.5, so 2.5. So 1.5 means the number which are lies between 1 to 1.5. Okay, so similarly 2 means 1.5 to 2, all those values which falls within that particular interval. Okay, so if we take the bin value, if we consider the width of the interval as 0.5, then the bin value is from 0.5, then next is 1. So 0.5 means that 0 to 0.5, then 1, then 1.5, then 2. Okay, although we know that the minimum value is 0.86, so it means that which is less than 1, so it means that obviously there will be no value in the interval 0 to 0.5. okay, so there is one value from 1.5 to 1 only. Okay, but anyhow, suppose we are constructing our bin in this particular way up to the interval say 10, because we know that the maximum value is 10 only. Okay, so we have constructed this. Now the next step is I want to find out the frequency, that how many numbers falls within this particular interval. Okay, so how can we find out the same? For the same we need to use this particular formula, that firstly we go to the option of a data, and then there is the option of data analysis, right? If you will not able to find out this particular option directly, in that case what can you do? You can go to the file, and there is a option is there. You can select this options, and there you need to go on the option of add-ins, and then you need to check that we need to add this option analysis to toolback. Okay, so how do we add this option? For that we can click on this go option, and if we need to click on this tool analysis toolback option. Okay, for example, if I untick this one, then you will find out that if I click on the option of data, then the data analysis option is not there, right? So how do I add this particular option? I go to the options, and then add-ins, there we choose the option of go, and then click on this particular option analysis toolback, and OK. So now you will find out here that when we select the option of data, then this data analysis option is there, right? So now how do we add get the frequency of the corresponding this particular interval? We click on the data analysis option, and there we need to choose the option of histogram, and then click OK. So it will require some input here. The first one is the input range. So the input range is this entire data, because I want to find out the frequency corresponding to this data. So for selecting this entire column, what I have done, so there are about 1739 entries. So to select this all these entries, I firstly select the first box, and then choose the option of Control Shift and down key. So automatically all the entire column is selected, right? Now the second step is we need to select the bin range. So for the bin range, again I am going to select this particular column, so from 0.5 to 10, so Control Shift and down key. So you will find out here from G3 to G22 all the terms has been selected. Now the next option is the output range, where you want to see the output, that is the bin and the corresponding frequency. So for example, I'll select the very next column, and I click OK. Then you will get this particular part. So the bin value and the corresponding frequency is there. So to calculate the next result, I firstly eliminate this additional box here, because after 10 there is no more options are there, so I eliminate this part. And now already we have the bin value, so again this table is also not required, so let us delete this part. Okay, so now we have the interval and the corresponding frequencies also there. Okay, so if you want to cross check, then you can see here the total sum of this particular column is 1739. Okay, even I can write the sum here. We can use the formula of sum of this column means shift, control shift and down key, so it will gives us the value as 1739. Okay, so the next step is I want to find out the probability. Okay, so for calculating the probability we are going to use the formula. What is the formula of probability? That if for example, that if we are say tossing a coin, if we are tossing a coin say 100 times, okay, 100 times, and number of heads, so out of these 100 attempts of tossing a coin, for example, we get 529 times we get a head. So what is the probability of head? This is equal to the frequency divided by the total number of times we have repeated this experiment. So okay, for example, 1000 times we have repeated the experiment, out of 1000 times 529 times we get a head. So how do we calculate the probability? It is the number of times head appear upon the total number of time we have repeated the experiment. So what is the formula of probability? Probability is frequency, okay, that is the number of time the event occur divided by the total sum of the frequency. Okay, so in this case, what is the frequency of getting a number between 0 to 0.5? It is 0. So to calculate the probability, we are simply considering this number divided by the total sum. Total frequency is 1739. Okay, so to get the all other probabilities, we simply drag this column, so we can get the all the probabilities, and to verify the answer, you can see here the sum of all the probabilities is equal to 1. Okay, so this is how we can calculate the probability. This is the actual probability, okay, based on the given data. Like I'm saying, if I toss a coin 1000 times, and out of 1000 times we get the number of head 529 times, so on the basis of that particular experiment, the probability of head is 0.529. so this is the probability on the basis of the experimental only. But otherwise we know that what is the probability of getting a head if the coin is unbiased? Its probability is 0.5. so this is the actual probability. Okay, so now this is the probability we have calculated on the basis of the actual data. So if we are assuming that this the population follow normal distribution, then how do we calculate the probability on the basis of normal distribution here? So again, so for that particular part, firstly we need to understand that there is one concept in a normal distribution, that when the data is in the discrete form, if the data is a discrete and the population follow normal distribution, and the population follow normal distribution, with mean say mu and variance say sigma square, then data is a discrete means that because for the normal probability, I already told you, we are normal distribution is a continuous probability distribution. So in that case, the first step is we need to convert the data into continuous form. So in that case, we need to calculate the continuity correction. And what is the continuity correction? Say it is denoted by delta. Then delta is equal to, that is the width width of the interval means, for example, the data is calculated to the nearest, say, zero point 0.5 zero point 0.5 unit. So the data is like 1, then 1.5, then 2, then 2.5, then 3, then 3.5. So in that case, this data is not in a continuous form. So in that case, what is the width between the two consecutive value? The width is 0 0.5. So what is the continuity correction? Continuity correction is width by 2. So basically what will happen, so when the data is given in the discrete form, we can plot the histogram that all the values between 1 to 1.5, say 1 to 1.5, it is plot in the form of a histogram, and then 1.5 to 2, say it is connected in this way, and then from 2 to 2.5 the data is like this. Okay, so in that case, to draw a continuous curve, so what can we do? We simply join the midpoint of these histogram, okay, and we connect them in the form of a line, so that will form a continuous curve, right? So for that particular purpose, if the data is given in a discrete form, then we need to consider continuity correction, which is equal to the width, that is the difference between the two consecutive time, divided by 2. For example, if we want to calculate the probability at a point x equal to a, so in case of the continuous random variable, the probability at a point is 0, right? But if we are given a discrete data, then the probability at a point exists, okay? But if we want to calculate the probability with the help of normal distribution, so firstly we need to convert this data into continuous form. So I can write x equal to a as a is less than equal to x is less than equal to a, right? So left limit and right limit is same, so it means that x equal to a only. Okay, so if we have a sign of equality, then we need to convert it into continuous form by adding and subtracting. In the left limit, we are going to subtract the continuity correction, that is a minus delta, and in the right limit we are going to add the continuity correction to convert this discrete into continuous form, okay. So we need to convert in this way, okay. So the rest of the process is same, like if we want to calculate the normal distribution, then this is the formula we have discussed, that a to b, how do we calculate it? We need to subtract mu divided by sigma and b minus mu upon sigma, right? So it means that here this is our a, basically this is our a, and this is our b, okay. So how do we calculate the probability in case of normal distribution? So we need to subtract the population mean divided by standard deviation, x minus mu upon sigma and b minus mu upon sigma, and we say name it as capital A and capital B, and so we have to follow the same concept whatever we have discussed here, right? This is equal to the cumulative distribution function of point B minus cumulative distribution of point A, okay. So let us calculate the probability here with the help of normal distribution. So for that part, the first thing is we need two information. The one is the population mean and the population standard deviation, okay. So because I am assuming this whole as a population only, so how do we calculate the mean? So for mean, the formula is average control shift down key, so we can have selected the entire data, bracket close, so that will gives us the mean value. And if we want to calculate the variance, or sorry, standard deviation is required. So standard deviation is, this is equal to standard. Now in standard deviation we have a two formula. One is standard deviation dot p. This formula is used for the standard deviation of a population, right? And if we use STDEV.S, so it is based on the sample only, okay. So but here we are considering this population, so we are going to use this formula of standard deviation. So for that, again we have to select the entire column, so from first entry to last, control shift and down key, bracket close, so it will gives us the standard deviation of the population also. So mean and standard deviation are known. So now we are going to calculate the probability using normal distribution. So what is the formula? So normal distribution. Now what is required for this particular formula? First one is, what is the value of x? So here this is our x, this is the bin value, right? But here we are going to use the formula of this one, right here. So in this case, what is x? Like I told you, so if I want to calculate the probability from A to B, now in this case at a point A, so we need to convert the data into continuous form. So in the left limit we need to subtract the continuity correction, and in the right side we need to add the continuity correction. And what is the continuity correction? It is the half of the length of the width of the interval. So the width of the interval is 0.5, right? So what we need to do, so in H3 we need to add the half of the width size. The width size is 0.5, so 0.5 divided by 2 is 0.25. okay, this is the upper limit. Then the second thing we required is the mean. What is the mean? This is the mean. So here we have added a dollar sign here, okay, and then we need to, the next one is we need to consider standard deviation. Again I am going to add the dollar sign here, and the next step is we are going to consider the cumulative distribution function, right? So I have added the option true. True represent cumulative distribution function. Copy this data, minus, again paste this data, and here we consider negative sign. Now I'll just tell you that what is the meaning of this particular formula here. So like I told you, so if I want to calculate the probability from the interval A to B, right? So what is the meaning of f of b? F of b means cumulative. So it means that we have calculated the normal distribution. So what is x here? Here x is a. In the left limit here, what is x? It is a in the upper lower limit, and b in the upper limit. So I am writing b here. So it means that here it is b. What is mean? We have considered mean as mu, standard deviation as a sigma, and because we have calculated the cumulative frequency, so we have used the option true for cumulative frequency. So this is the meaning of f of b. Minus f of a means again normal distribution of the lower limit. What is the lower limit? This is a, where mean is mu and standard deviation is sigma, and again we have calculated the cumulative distribution function, so we have used the option of true here. Okay, so what is the meaning of this particular formula? So upper limit, mean, standard deviation, cumulative distribution, lower limit, mean, standard deviation, and cumulative. Now the second thing is why we have added here a dollar sign. So we have added here a dollar sign because this particular box is fixed, because otherwise what we have done, for example, I have calculated this probability. Now to calculate the next probability, what I am going to do, I am going to drag this particular box, and we can calculate all other probabilities also. Okay, so you can see here, when I move to the second box, then the value of D7 remain fixed, but here H3 become H4. You can see here we have H3, but here we have a H4, here we have a H5, but the value of D7 remain fixed. But if we are not using here the dollar sign, then you can see, for example, here I remove this dollar sign, then what will happen? So in that case, here we have a D7. When we move to the next one, if I drag this particular formula here, okay, then what will happen? You can see here it become D8. Okay, so why we have used this dollar sign here? So dollar sign means that I fix this particular box. Okay, so now if I drag this particular formula, then we can get the desired probability, and you can see here the sum of all these boxes is approximately 1 only. Okay, so this is the probability we have calculated with the help of normal distribution. Okay, now I have calculated the normal probability, I have calculated the actual probability. Now the next case is I want to see that what is the nature of the distribution, because this is the normal probability. It actually have a normal distribution like a curve, but I want to see that what is the nature of this particular part. So although if we check the difference between these two value, if we calculate the error, so we can say this minus this, and if we calculate this value in the absolute form, say, okay, so that means we ignore the negative sign, then we find that the difference is small. So it means that almost these two values are same only. Okay, to get more clarity, what can we do? We can draw the diagram also. For example, I've selected Control Shift Down key. This entire column has been selected, sorry, but we need the value of X, that is Control Shift Down, then release the shift button, but we have already pressed the control button. Now select this box and again Control Shift Down, again release the shift button, then Control Shift and Down. So we have selected these three boxes, and now if I plot this particular then what we have here, there are two options. Either we can select the column graph, so there we will find out here this orange lines represent the graph of a normal distribution. You can see here it is a symmetric graph, but on the other hand this blue lines represent the actual probability curve. So you can see here the nature of this curve is approximately normal only. And if you remember, in a central limit theorem we have discussed that every distribution tends to the normal distribution when the sample size is large. Okay, so although here we have considered about 1739 entries, so the approximate nature of the curve is normal only. Okay, so this what we'll get from this particular activity, that how can we calculate the probability of a discrete distribution, and if we want to calculate the probability for the normal distribution as well, this is how we can calculate the probability. Okay, so one more thing, like if we want to calculate the probability, for example, especially in case of the discrete data, if we want to calculate the probability, say between say 4 to say 6.5 CGPA, right? So how do we calculate this? There are two ways. One is, if the actual data is present there, then with the help of the data only we can see that what is the value less than greater than 4 but less than 6.5. So greater than 4 means 4.5 and less than 6.5 is 6, right? Greater than 4 means 4.5 and less than 6.5 means 6 only. So we need to check the probability at x equal to 4.5 and x equal to 5, then x equal to 5.5, and then x equal to 6. This is how we can calculate the probability from the actual data. But if we want to calculate the probability using normal distribution, right? So what we have to do? So the first step is, like in this particular part, we need to firstly convert this data into equality form. Okay, so like we have already seen that here the width size is 0.5. So after 4 the next point is 4.5, and before 6.5 the data is 6 only. Okay, so firstly we need to convert inequality into equality, and then we need to add a continuity correction here. So what is the continuity correction? 4.5 minus 0.25. We need to subtract 0.25 from the left limit, and we need to add 0.25 in the right limit, so that the data will be converted into continuous form. So it is 4.25 to 6.25, right? And then we need to subtract mu, that is the population mean, divided by standard deviation, x minus mu upon sigma. 6.25 minus mu divided by sigma, and say this is A and this is B, and then we can calculate probability z is less than equal to B minus probability z is less than equal to A. Okay, so what is our B here? So if we want to use the formula, so what is the formula? Normal distribution. What is our x? X is 6.25. What is our mean? Mean is mu. What is standard deviation? Sigma. And for cumulative frequency we need to use the formula of true. And again, normal distribution, x is our 4.25, mean is mu, standard deviation is sigma, and for cumulative frequency we need to use the command of true. This is how we can calculate the probability using the normal table. Okay, for example, like here, if I want to calculate the probability, okay, for this particular data, right, what can we do? So we are using the formula normal distribution. So what is x? Say for example I want to calculate from 6, so 6 plus 0.25, so the mean is, this is the mean value, so we added here the dollar option, although we need to calculate only one term only. So standard deviation, this one, again we need to add here dollar sign, and then we use the option of cumulative frequency, so I'm using true, bracket close, minus. So again I'm going to copy this data. The next one is, so for what value we want to calculate, this is for 4.25, that is 4.5, so 4.5, this is 4.5 minus 0.25. So this will gives us the probability which lies between 4 to 6.5. okay, so this is the answer of this particular question. So I hope you will be able to understand that how can we perform the activity based on the normal distribution. If you have any doubt or any query, you can post your query. I'll try to provide you the solution of this. Right, thank you all of you, have a nice day.